it would be helpful for you guys. I've given you the graph of what I'm saying is a velocity function. Okay, v of t is what I'm calling it. The rate of change of velocity with respect to time, v prime of t, is acceleration. So I ask you to sketch the graph of v prime of t. You could get a sketch just from looking at this, but it would be even more helpful if you were to determine the equation of v of t. Now you can see that the vertex of v of t is at, was that 4, -4? So like in vertex form, v of t would be a times x minus 4 squared minus 4. From a transformation perspective, like you said, Jake, or from an algebraic perspective, you could think about solving for what a would be. Like from transformations, if you're like, oh, hey, if we go to the left 2 and up 4, like that's a point on the parent function x squared. So there has not been any sort of dilation, meaning a would be equal to 1. You also could have thought about plugging in another point. Like this is the point 0, 12. If you were to plug in like 12 and then 0, or there are other values you could have plugged in, right? Like you would have, what did I do wrong here? I did something wrong again. No, I didn't. I'm okay. I left off the exponent of 2. There we go. So then we'd have 16 equals to a times 16. So a is equal to 1. Yay. That was what was supposed to happen. I got nervous there for a second. So v of t is equal to the quantity x minus 4 squared minus 4. Did we all get that? Yes. Meaning that v prime of t would be equal to, oh, you would have to multiply that out because you guys don't know chain rule yet. Okay, so if we multiply this out, that's x squared minus 8x plus 16 minus 4. So x squared minus 8x plus 12. And oh, you guys, I made a no-no. I changed my variable. I'm like, I need to get it together. I think this is the last class I'm teaching for just today, and it's probably a good thing because I keep making mistakes. Okay, hold on.
Oh,
it changes back. It's driving me nuts.
I think notability updated and then it changed it back for everyone. Yeah, just turn it off.
But it's, how do I turn it off?
Just turn off the double tap to.
Okay, yeah, how do I do that?
Go to your settings. No, it's different.
Here, Violet, you
Then it goes to
Violet, it's in settings.
Okay.
Go to the notability settings.
Notability settings.
That was frustrating. So v prime of t, then thinking about power rule, would end up being 2t minus 8. Right? So v prime of t is what we could call a of t for acceleration if you wanted to, since I reference a of t. So then graphing a of t, this is going by 1, so that would be -8, and then a slope of 2. This also should make sense, you guys, because looking at where the horizontal tangent line would be at t equals to 4, right? T equals to 4 would be horizontal tangent line, which would correspond to the x-intercept or the t-intercept in this case for v prime of t. So acceleration is the rate of change of velocity. So the derivative, acceleration is the derivative of velocity. Remember velocity, we talked about this last time, is the derivative of a position function. And then the derivative of velocity is acceleration. So how velocity is changing is acceleration. Okay, so we have our acceleration graph. Speed is the magnitude of velocity, which means that speed, I'm using S of t to represent speed, is the absolute value of velocity. If you remember, I talked about this when we talked about transformations way back when in pre-calc, about how you could think about absolute value as being a transformation. Like if you take the absolute value of a function, all of the positive parts of the function's graph, like all the values that are, or points that are above the x-axis would stay the same, and anything that's below the x-axis would then be would be reflected over the x-axis. So like if we think about the graph of v of t, which has the vertex at 4, -4, so the vertex is right here. Sorry, this is a different scale, so I just want to kind of sketch this quickly. 1, 2, 3, 4 here, and then where are we? 2, 3, 4, 5, 6, 7. Oops. Okay, so this would be the graph of v of t. So when we think about taking the absolute value of v of t, the positive values stay where they are. But all of these negative values get reflected across the x-axis, or the t-axis in this case. So this is what the graph of s of t would look like. Are we okay with that? These are pre-calc definitions of increasing and decreasing. So then for thinking about where or on what intervals does it appear that the speed is increasing? It looks like speed is increasing, and we're looking at the graph of the speed function, right? Speed is increasing on the interval from, what is that, 2 to 4? 2 to 4? As well as from 6 to infinity. Do we all agree with that? Okay. And then for where speed is decreasing would be from -infinity up to 2. And then, what is that, 4 to 6. So now kind of putting it all together and filling in what the sign, and by sign I mean positive or negative, is for each of these intervals, for each of those functions. So for velocity as well as acceleration. So on the interval from -infinity to 2, we're talking sign, so positive above the x-axis or below the x-axis. For velocity, from -infinity up to 2, velocity is positive, yeah? What's acceleration? Negative. Okay. On the interval from 2 to 4, you guys got velocity is negative, and acceleration is negative. Okay. From 4 to 6, velocity is negative. Acceleration is positive. Okay. From 6 to infinity, velocity is positive, and acceleration is okay. So to go back up here and kind of put this all together. So we saw that from 2 to 4, speed was increasing. How do I make this larger? Let's make this larger. So 2 to 4, speed was increasing, as well as from 6 to infinity. And then we saw that from negative infinity to 2, speed was decreasing, as well as from 4 to 6. So again, putting it all together, relating velocity and acceleration to speed, we can say that when the sign of velocity and acceleration are the same, then speed is increasing. And when the sign of velocity and acceleration are different, so one's positive, one's negative, we can say the speed is decreasing. This interpretation, I guarantee, will come up. And there is a strong possibility, a very strong possibility, that you will have part of a free response question related to is the object. We're going to get deeper into linear motion. So if you're thinking about an object either moving one of two directions, like forward, backward, up, down, left, right. And it's a strong possibility that you would be asked a question about, is the object speeding up on this interval? Is the object slowing down on this interval? And you would need to justify. Your justification is the signs of acceleration and velocity. So in order to justify, hey, the object is speeding up on this interval, you would be like, velocity and acceleration are both negative. Or you could say velocity and acceleration are both positive. Does this make sense? This is something that I don't know if you want to put like stars next to it. It will come up over and over again. You need to know this relationship. That was like a weird thing to put. That the sign, positive or negative, of velocity and acceleration are the same for speed to be increasing, and the sign of velocity and acceleration are different if we say the speed is decreasing, or for the speed to be decreasing. This is so important. Oh my gosh, I finished in like perfect time. Do we have any questions? And we are going to get deeper into what we call linear motion, but this is kind of setting us up for looking at those types of problems, which we can look at as an application of derivatives. Okay.